Here we have the function 0.3x squared minus 4, and this is what the graph looks like. And this graph has what we call zeros of the function, or the x-intercepts of the function. One x-intercept looks like it's about negative 3.7. That's where the graph crosses the x-axis. And then the other one is on the other side of the y-axis, so it looks like it's about 3.7. So we like to find these x-intercepts right here. And normally what we do in finding x-intercept is just set the function equal to 0 and then solve for x. And that will give us the x-intercept. There are many cases where the function, when we set it equal to 0, is too difficult to solve for x. And so what we have to do is we use what's called Newton's method. To find the zeros of the function or the x-intercepts of the function. And so let's say we want to find this zeros right here, or this x-intercept right here, this 0 of f of x. So the x-intercept of a function, we call it the 0 of the function. And so what we do is this. So this is about 3.8. And so first what we do is take a guess. So what we guess, meaning pick the number near this 3.8 right here. And so let's say we pick the 1. So we pick this 1 right here. And so when we pick the 1, when we let x be 1, then the corresponding y will be negative 3.7. And so what we want to do is draw a tangent line through the point negative 1, through the point 1, negative 7. And so here we drew the tangent line at the point negative 1, at the point 1, negative 3, 7. And then next, what we do is we find the equation of this tangent line, and then find the x-intercept of the tangent line. And so we would get the slope of the tangent line, we will get it through the derivative of the function. And so in this case, the line passes through the point 1, negative 7. So the slope of this tangent line will be the derivative at 1. And so the derivative at 1, evaluate the derivative at 1, then we get 0.6. And so the equation of the tangent line passing through the point 1, negative 3, 7, with the slope of 0.6 will be y equal to 0.6 times x minus 1 plus 3.7. So this is the equation of the tangent line. And now what we want is the slope of this tangent, the x-intercept of this tangent line. We want to know where does the tangent line crosses the x-axis. So it looks like it's very close to 7. And so to find the x-intercept of the tangent line, we let y be 0. And then we let y be 0 and then solve for x. Then this is what x equals to. So x will be equal to 1 minus negative 3.7 dividing by 0.6. So once again, to find the x-intercept of the tangent line, let y be 0 and solve for x. So let's write that down. To find x-intercept of tangent line, let y be 0 and solve for x. And so we let y here be 0 and then solve for x, then we get 1 minus negative 3.7 dividing by 0.6, which is going to be the x1, which is our initial guess, which is the 1 right here, and then which is the 1 right here, and then f of x of 1, which is the negative 3.7, and then dividing by the derivative of f of 1, which is 0.6. And so the x-intercept comes out to be 7.16 or 17. And then the next thing we do is we compare the initial guess with the x-intercept of the tangent line. And we find that difference. And let's call that difference d sub 1. So it would be 7.16 minus 1, and we get 6.616. And then this number will become important, as we will see. And so after this is called an iteration. So after the first iteration, we found the first tangent line, and then we found the x-intercept of the tangent line to be at 7.1666. And so we would continue on to what we call iteration number 2. And in iteration number 2, we would let the guess, we would guess that the zero of the function be the x-intercept. So initially we guessed it to be 1. And so in the next iteration we will let the guess of the zero of the function be the 7.1667 right here. And then if we guess it to be this point, then we would find the corresponding y, which is right here, and then draw the tangent line at this point. So if our guess is 7.1666, then the corresponding y on the graph will be 11.4. And so now we have 7.16 and 11.4, and then we're going to draw a tangent line through that point, and then find the x-intercept of that point. And so now let's draw the tangent line through this point right here. And so this is the point 7.16, which comes from this x-intercept, the x-intercept of the first tangent line, and the corresponding y is 11.4. And so at this point of 7.16 and 11.4, we would calculate we would find the equation of this tangent line, and then find its x-intercept. So for tangent line number 2, it passes through the point 7.16 and 11.4. The slope of the tangent line number 2 will be the derivative evaluated at 7.16, because that's what the derivative is the slope of the tangent line, and we get 4.3. The tangent line passes through this point and has a slope of 4.3, and therefore the equation of the second tangent line is 4.3 x minus 7.1666 plus 11.4. And now we want to find the x-intercept of the second tangent line. And again, define x-intercept, let y be 0, and solve for x. And so right here, if we let y be 0 and then solve for x, then we will get 7.166 minus 11.4 divided by 4.3. So that's the 7.16, that's the 11.4, and there's the 4.3. And we would get 4.5. And so this is the x-intercept of the second tangent line. And now compare the initial guess, the guess of the zero of the function, with the x-intercept of the second tangent line. And that difference will be 2.65. And we call that d sub 2. And then we will continue on to the next iteration. In the next iteration, our guess for the zero of the function, the zero which is the x-intercept of the function right here, our guess would be this x-intercept. and we found that x-intercept to be 4.5. So this x-intercept right here, the x-intercept of the second tangent line is 4.5135. And so in iteration number 3, our guess of the zero function will be 4.513566. And then we would go through the process all over again. So this time we guess that the zero of the function, or the x-intercept of the function, is 4.513566. And so next we would find the y, which is the y corresponding to an x of 4.51. It's going to be 2.11. And so that point is going to be about right here. And then we would draw a tangent line through this point. And so let's draw a tangent line through this point. And so once again, to get for iteration number 3, we let the guess of the zero of the function to be 4.5. And then we found the corresponding y, which is 2.11. So this point right here is going to be 4.5 and 2.11. And then we draw a tangent line through this point, which is the green line. And now we see that the x-intercept of the green line is very, very close to the x-intercept of the function, of this function right here. And that's what we want. And so now let's find the x-intercept of the green line, which is going to be very, very close to the x-intercept of the function. The third tangent line has an x that passes through the point x of 4.51, and the y is 2.11. So the slope of the third tangent line would be the derivative evaluated at 4.51, and that comes out to be about 2.708. And so the equation of the third tangent line would be y equal to 2.708, which is the slope of the tangent line, and then x minus the 4.5, and then plus the y, which is the 2.11. And then to find the x-intercept of this tangent line, we would let y be 0 and solve for x. And if we do that to solve for x, then x would be 4.5, which is the 4.5 right here, minus the 2.11 dividing by the 2.7, and we will get 3.73. And now we want to compare this 4.5 with the 3.73. And that difference is 0.7797. And what's going to happen is we will continue on to the next iteration until the difference is real small, like 0.000 something. And then we would stop. And so in the next iteration, our guess of the zero of the function would be 3.7338. And so this will be 3.7, this right here, this is about the x-intercept of the third tangent line, where x is 3.7338. And so in the fourth iteration, our guess for the zero of the function will be 3.7338. And so here's our fourth iteration. And so this time the guess for the zero, the function, will be 3.733, which is the x-intercept of the green, of the third tangent line. And now we're going to find the corresponding point. So when x is 3.7338, then the corresponding y would be 0.1824. And so we would locate this point on the graph. And so that point is going to be about right here. And then we would draw the tangent line through this point. The slope of the fourth tangent line be the derivative evaluated at 3.7338, and that comes out to be 2.24. And so the equation of the fourth tangent line would be y equal to 2.24, which is the slope of the tangent line, and then x minus 3.73, and then plus 0.18. And again, we want the x-intercept of this tangent line. And to find the x-intercept of this tangent line, let y be 0, and then x, solve for x. Solve for x. So let y be 0, and then solve for x. And we will get x to be 3.7338 minus 0.182 dividing by 2.24, and that comes out to be 3.65. And now we compare the guess with the new x-intercept of the tangent line, and that difference comes out to be 0.08. And now let's draw the fourth tangent line. And the orange line here, that's the fourth tangent line. And so what we've seen here is this. This is the blue line, that's the first tangent line. The red line is the second tangent line. The green line is the third tangent line. And then the orange line is the fourth tangent line. Each time the x-intercept is moving closer and closer to the x-intercept of the function. So the first x-intercept is here, the second x-intercept, the third x-intercept, the fourth x-intercept. And so that's what Newton's method is about. So first, we have start with an initial guess, then we get a x-intercept that's a little bit away, that's a little bit apart from the zero of the function. And then we move closer and closer and closer. And that's where that difference down here will tell us how close are we. And so when this difference is real small, then that tells us that that we are very close to the zero of the function. And so for iteration number 4, the x-intercept of the tangent line is 3.65. And now we would go to iteration number 5. And when we go to iteration number 5, the guess for the zero of the function will be 3.65. So it will be 3.652391. And the corresponding y for an x of 3.65 is 0.001988. And so now we want the slope of the tangent line, which is this new line right here. This is the light green. And so it would be the derivative evaluated at 3.65, and that comes out to be 2.19. And so the slope of the fifth tangent line is 2.19. And so the equation of the fifth tangent line is y equal to 2.19 x minus 3.65 plus y of 0.0019. And again, we want the x-intercept of this tangent line. And to find the x-intercept of this tangent line, let y be 0 and solve for x. And if we solve for x, we get 3.65 minus 0.0019 dividing by 2.19. And that would be 3.65. And now compare the initial guess with the new x-intercept of the fifth tangent line. And then that difference is 0.0009. And then what's going to happen is, if we go to the sixth iteration, then we'll get more zeros right here. And then if we go to the seventh iteration, we'll get more zero. And let's say that we're happy with this difference. If we're happy with this difference, then we would say that the initial, zero, we would let 0 of f of x, or the x-intercept of the function, would be 3.651483. And then, like it said, if we're not happy with this difference right here, we want more zeros here, then we would continue on to the next, the sixth iteration, the seventh iteration, the eighth iteration, and so on. And so that's how we would use Newton's method to find the zero of a function, this point right here. Now, this particular function has a 0 on this side, and it has a 0 on this side. And so, normally, to start with an initial guess, we just pick any number to the left or to the right of the 0. And so, normally, what I would do is just pick the number to the left of the 0. And so, if I want this, to find this 0 right here, then we can start with a negative, an initial guess of x equal to -5, and then go through all the iterations, and it will give us this 0 of the function right here. So we have to do them one at a time to get the 0 of the function. And so in summary of Newton's method, so we want to find this 0 right here, 0 of the function. We want to find this x-intercept, and we start with an initial guess of x equal to 1. Then we would find the the tangent line at the point with x equal to 1, and then we get an x-intercept of the first tangent line. And then we would use this as a guess of the 0 of the function for the second tangent line. And then find the second tangent line. And our second tangent line is going to have an x-intercept that's closer to the 0 of the function. And then our third x-intercept, our third tangent line, will have an x-intercept that's even closer to the 0 of the function. And then our fourth tangent line will have an x-intercept that's even closer. And then our fifth tangent line will have an x-intercept that's even closer. And if we want to move even closer, then we would go to the sixth iteration, and we get another tangent line with an x-intercept that's even closer to the 0 of the function. And then if we want closer, then we will go to the seventh iteration, and we will get a tangent line with an x-intercept that's even closer to the 0 of the function, and so on. And so that's Newton's method for finding zeros of functions.